So we're looking at that exact versus ordinary interest. So let's do some examples here. So we're going to find the maturity value for a 120-day $6,300 loan at 7.3% exact interest. It'll either say exact, or if it does not say exact, you'll always assume ordinary. So we're finding I here. Tell me what else to fill in here. 6,300 is my principal. The rate of 7.3% is 0.073. 120 over, and it's exact, so it is 365. So 6,300 times 0.073 times 120 divided by 365. $151.20. Now, in this case, did it ask for the amount of interest, or did it ask for the maturity value? Maturity value, which means we have to go one more step. It's the 6,300 plus 151.20. So it's $6,451.20. Find the maturity value for a $4,500 loan at 8.7% for 150 days. Where do I start?
$4,500.
Yep, I equals 4,500. 0.087 for the 8.7%. $150 over 360 is our time, because it says, does not say ordinary or exact, so we assume ordinary. So 4,500 times 0.087 times 150 divided by 360. $163.13 if we round it off. Again, do we stop there or do we have to go another step? Another step, because that's maturity value. Very good. So 4,500 plus the 163.13 gives us 4,600, bless you, $63.13. Find the exact interest on $2,700 borrowed at 11.2% for 60 days. Maybe try that one in your notes. We'll talk about it in a minute or so. So to set this up, we've got I equals 2,700 times 0.112 is our rate times 60 over 365. Because I said exact interest. So 2,700 times 0.112 times 60 divided by 365. $49.71. Do I have to go to the next step? No, because I just say find the interest, not the maturity value. Now this next one's going to be a little interesting. Find the amount saved by using exact interest instead of ordinary interest. On a $4,600 loan at 9.3% for 105 days. I'm going to let you guys try that one quick and we'll talk about it in a minute. So we have to do this one both ways. I'm going to start out with the ordinary interest. So it'll be $4,600 times 0.093 times perfect. 105 over 360 for the ordinary. 4,600 times 0.093 times 105 divided by 360. 124.78. Let me see, something I just got punched in wrong, I'm thinking. Now for exact, everything looks the same, so 4,600 times 0.093 times 105 over, the difference is over 365. Good. Giving us 123.07. So we subtract, we have a difference of $1.71. Any questions? On May 18th, Pat borrows $8,400 at 10.4% exact interest. How much is paid back on July 11th? Here's where we need that date table out of the book. May 11th is what day of the year? 138. July 11th? 192. Does that look right? 138, 192. So 192, they're in the same year, so we can just subtract them. 192 minus 138 gives us 54 days. So now our interest is our principal of 8,400 times 0.104 times 54 over, and it does say exact, it's over 365. I get $129.24. Is that what it's looking for? It says how much is paid back, so it wants the maturity value. 8,400 plus 129.24, $8,529.24. If Devin borrows $1,700 on November 28th, at 7.8%. How much is paid back on March 4th? First thing, table in the book. November 28th is what day of the year? 332. March 4th? 63. Okay. Now this goes, these are in different years. So I'm going to go November 28th to the end of the year and then up to March 4th. So I have to do 365 minus the 332 gives me 33 days from March 28th to the end of the year. Then I have 63 days from the beginning of the year to March 4th. So that combines to give us 96 days. So interest is going to equal, fill in the blanks for me. 1,700 times 0.078. 96 over, it doesn't say anything about exact or ordinary, so we assume ordinary. So 96 over 360. So $35.36.
Okay, hold on.
Yes.
We just divided 96 by 360, but in order to get the number of days, we did 365.
Wonderful question. I was waiting for that one to come up. Why is it that we only use 360 here, but when we calculated the days, we use 365? And to be honest, I don't have a great answer for that. But they still use, even though it's ordinary interest, they still use the exact number of days. So they still figure out, so I mean, if it was a full year, let's say you borrowed on November 2nd and paid it back like October 31st, so that's 363 days. At ordinary interest, they would still put 363 over 360. So even though it's been 2 days less than a full year, they're going to charge you for 3 days more than a full year. So they still count all 365 days, but they only put 360 in the denominator. I was waiting for that one to come up. That's a wonderful question. Now we've got to finish this one off. We're asking how much was paid back. So we do have to find the maturity value. So 1,700 plus the 35.36. So $1,735.36. Really, the best answer I can give you to that is if they don't count all 365 days when they're counting days, they can't get extra money out of you. It's actually kind of, like I said before, back in the day when it was all done by hand, pretty much all calculations were done out of 360. And every month was considered to be 30 days. Now that we have technology, if you have a loan and you're paying interest to the bank figures that interest as ordinary interest. If you have money on deposit in a savings account, they generally figure your interest as exact interest. Yeah, I know, it's crooked, but such is life. As long as they disclose it in the small print, there's nothing illegal about it. As long, I mean, if you ever read through a loan contract, if you actually read a loan contract word for word, there's a lot of stuff they disclose in that small print. Especially in a home mortgage. I mean, they might write you a mortgage at 3.2%, but when you read the small print, they actually, all the closing costs, because I mean, some of those mortgages to get down to those low rates, they charge like $4,500 up front. So when they actually divide that up amongst the life of that loan, that 3.2% may turn into 3.7% effective rate. So I mean, there's a lot of stuff like that that are in the small print of those loans that you should read. Now, what type of loan do we have that's typically ordinary interest? Believe it or not, the two most common types of loans our ordinary, or not ordinary, but simple interest. The number one that's usually simple interest is a home mortgage. The number two one that's usually simple interest is an auto loan. In today's day and age, that includes auto loans, boat loans, ATV loans, snowmobiles, stuff like that, recreational vehicles. Now, on a home mortgage, if it's a 30-year mortgage, obviously that doesn't mean they figure out all the interest for the 30 years and add it in at the end. How is it that they can get away with doing simple interest on these loans? Well, on simple interest, interest is calculated in one of two cases. One, at the maturity of the loan. Or two, when there's an action on the loan. Now, an action on the loan would be withdrawing money or paying money. What do you have to do every month on both of these loans? Make a payment, yes. So every time you make a payment, that is an action on the loan. So the interest is always figured out first before any action is taken. So whenever there's an action taken, interest is added first. Then the action is taken. The action is performed. I don't know why I wrote that so small you can't read it, but you get the point. So for an auto loan, we'll do that easier just because it's smaller numbers. A mortgage would work the same way. So for an auto loan with a balance of $12,864 that is at, well, let's say you got in the good interest rate. You got 3.2% interest on it. Let's say the last payment was on March 11th. You're going to make a payment of, let's go $320 on April 5th. Let's figure out how that impacts the loan. Now, why did I have to tell you when the last payment was made?
You need to know how many days in between.
Exactly. I need to know the days in between. We know that at this date, the interest was figured in and added in. So the interest is current up to that date. So before we can make this payment of $320 on April 5th, we have to get the interest current. To do that, we need the days. So in your little magic little table, what is the number for March 11th? 70 days. And for April 5th? 95. So that is a difference. 95 minus 70, 25 days. So before...
Is this why, like on house loans, where they have you pay every 2 weeks, you're supposed to be able to get your house paid off that much quicker because you're shaving off interest?
There's actually two reasons behind that. One is, yes, you're shaving off 2 weeks of interest every month. So that makes it significantly faster. The other thing is if you get paid every 2 weeks and you have it automatically taken out of your check, well, that's 26 payments a year instead of 24 payments a year. So in effect, you're paying an extra month every year. So there's two reasons why that shaves off interest. So now let's take a peek here at what the amount of interest is here. The interest is going to be that principal of $12,864 times 0.032 for a 3.2%. Now, did we state exact or ordinary? No, we didn't say anything, so we're going to assume ordinary. So 12,864 times 0.032 times 25 divided by 360. We got interest of $28.59. So before that payment can be made, we have to update the balance before the payment. That's going to be the 12,864 plus the 28.59, which is going to be $92.59. So that's the balance before the payment. Then we can subtract the payment. $320. So the balance after the payment is $12,572.59. Now I'm going to show you something that banks hate. In fact, several banks have actually now put it in their loan contracts that you can't do this. I'm going to use some relatively simple numbers here. On January 1st, you owe $10,000 on a car loan. And let's say you got a little higher interest rate. So we're going to do 7.5% car loan. That $10,000 is with the interest current. So on January 1st, you figured out the interest and you added the interest into the account. Let's say your monthly payment is $500, just to make life simple. On January 1st, you have the extra money, so you are going to pay 3 payments. So that means took your $10,000, you're going to subtract from that 500 times 3, which is 1,500. So your balance was 8,500. I want to find the balance on April 1st. The reason I chose April 1st is April 1st is 3 months from January 1st. So April 1st is how many days? Well, they're probably going to be figuring ordinary interest, but we'll figure it out. April 1st is what day of the year? 91. January 1st was day 1, so that's 90 days. That works out perfect. So our interest is going to be that principal of $8,500 after we made our payments times, what did you say, 7.5%? Yeah, 7.5%. So 0.075 times 90 over 360. 8,500 times 0.075 times 90 divided by 360. $159.38 is the amount of interest. So we add that to the 8,500. Equals $8,659.38. What would that balance have been if we had made the payment on the 1st of every month? So on January 1st, we paid $500. So the balance on January 1st was $10,000 minus $500, or $9,500. February 1st, we pay another $500. That's 31 days. So our interest, 9,500 times 0.075 times 31 over 360. Okay, $61.35. So we take the 9,500 plus that interest of $61.35 to get our balance before the payment of $9,561.35, and then we subtract that payment of $500. So our balance after the payment is $9,061.35. On March 1st, you make another $500 payment. From February 1st to March 1st, assuming a non-leap year, is 28 days. So we're going to take that $9,061.35 times 0.075 times 28 over 360. So 9061.35 times 0.075 times 28 divided by 360. I had interest of $52.86. So what that means is my balance before the payment, I take the $9,061.35, I add the $52.86, get $9,114.21 is my balance before the payment. Subtract the $500 payment. The balance after that March payment, $8,614.21. We still have to get to April 1st. On April 1st, we're not figuring in a payment here. We're just figuring out the balance from March 1st to April 1st is, March is 31 days. So we're figuring out that interest of $8,614.21. times 0.075 times 31 over 360. $8,614.21 times 0.075 is our rate, times 31 days over 360 for ordinary interest. So $55.63. So the balance before the payment, well, we're not going to make the payment, but the balance before interest, $8,614.21. Be adding that interest of $51.63. Is $8,669.84. Now remember, we're going to compare that to 86.59.38, this value right up here. So by making those 3 payments all on January 1st instead of doing 1 payment every month, you've saved a little over $10 in interest, $10.46 in interest. Banks hate it when you do that. By the way, there are a lot of banks. RCU in town here is one of them. I know did this several years ago. The only reason I bring it up is because I know several people that have gotten in trouble over it. You cannot pay more than 2 months ahead. And if you've paid more than 2 months ahead, any additional payments you make go to principal, not to future payments. And the reason I bring that up is people have gotten in trouble. So let's say today I get my tax refund. So I decide I'm going to make my next 6 months worth of car payments. So I'll make April, May, and I think I'm making June, July, August, and September. But what they did is they took the April and the May payments, they made those, but the rest of it just went to principal. Come June, even though I've paid that large amount, I still owe my June payment. So you've got to be very careful with that. Well, they will apply it to your principal. But some banks, what they'll try to do is they'll say, hey, we'll put that in an escrow account for you, and we'll make those payments as they come up. The problem is that escrow account doesn't give you any interest, and you're still paying interest on your loan. It's I think the previous word we used was steep.
But if you're paying down that principal, doesn't that still that you're still saving something on your interest?
You're still saving interest, but a lot of people think, okay, I've made my payment, so now I don't have to worry about coming up the money in June. Well, June comes along and I've got to come up with the money for that payment because they applied it towards the principal instead of the payment. So it's something to ask. I know I've worked with banks. I like to work with banks that don't have that because I'm one of those that when I get a tax refund or I do other projects, like I run a construction company, I do textbook writing and stuff like that. When I get those bonus checks, I like to pay off my loans and get 5-6 months ahead on my loans. So that's my you talk about your emergency fund. That's my emergency fund is I know that if something goes wrong, I can go 3 or 4 months without paying on my loans without having to worry about it. But some banks don't allow you to do that. I know some banks don't allow you to make past the current payment. I believe Wisconsin Credit Union, if you can make your current payment, but you cannot pay ahead. If I subtract them out, it's like $10.46. The 86.59.38 is what I had before. And I got the 86.69.84 on the second one. Okay. What we just did here, by the way, in this last example, we made partial payments on a loan. In fact, the technical term is partial payments on a note. And what we did is referred to as the U.S. rule. In the U.S. rule, you assume ordinary interest and you count days exactly how we did. And that's what the U.S. rule is for figuring out what is the amount, the balance after each payment, and then the balance due at the end. So let's take a look at Chris borrows $4,800 at 12.3% for 90 days. On day 32, Chris pays $1,500. On day 59, Chris pays $2,000. Find 1, the amount due, the balance due at maturity. In other words, the balance due at the end. And 2, the total interest paid. So what is the first action on this note? Day 32, they made a payment of $1,500. So that's our first action. The days have gone by as 32 because we started from the start to day 32. We've nothing else happened. So we're going to figure out our interest. Our principal is $4,800 times our rate of 0.123 times 32 over 360. $52.48. So that means is we're going to take that $4,800. We're going to add the $52.48. $4,852.48. What is the balance before the payment? Then what? Make the payment. Subtract $1,500. Which gives us $3,352.48. The balance after the payment. What's the next action on the note? Day 59, she pays $2,000.
So it's actually 27 days later, is that right?
Exactly. So $2,000 payment on day 59. That is our first thing we have to do is figure out the days. 59 minus 32 is 27 days. So now for our interest, we have to take the balance after that last payment, $3,352.48 times, well, still 12.3%, so 0.123, and then 27 days over 360. So 3352.48 times 0.123 times 27 divided by 360. $30.93 is our interest. So that means take the $3,352.48. We're going to add that $30.93. You get $3,383.41 is the balance before the payment. And then subtract the $2,000 payment. It's $1,383.41. Is the balance after the payment. The final action on this note. Doesn't look like there's any, but it is maturity, 90 days. Day 90 is maturity. First step is still the days. So our last action was day 59. So we're going to do 90 minus 59 is 31 days. So we calculate our interest. I equals, we use our balance after that last payment again, $1,383.41. Our rate is still 12.3%, so 0.123. Now we just found our new time to be 31 days. So 31 over 360. So we'll punch that in. 1383.41 times 0.123 times 31 divided by 360. Give us $14.65 in interest, which is going to get added to the $1,383.41 It was $1,398.06. That is the balance due. So that's the balance due at maturity. So that's how much they have to pay on that 90th day. Total interest, $98.06. How did I find that? Well, we have to go back up here. We've got the first interest of $52.48. The second interest of $30.93. And then the last interest of $14.65. $98.06. What do you think? It is time for a break. So let's go ahead and take a break. We'll come back at 7:35.